All right, today we're going to do chapter 5 homework and the problems 41, 45, 53, 57, 61, 73, and 81. Let's begin. Problem 41 states a 7.6 kilogram object rests on a level floor with a coefficient of static friction of 0.55. What minimum horizontal force will cause the object to start sliding? Well, we have to overcome that friction. So we have 7.6 kgs. The friction is the normal force times 9.8 meters per second squared times the coefficient of static friction 0.55. No units there, note. And for that, we are going to get, let's see. That value will be 41 newtons. So pull it with a force of 41 newtons and you will overcome that static friction and it will slide. All right, number 45. Number 45 reads, a horizontal force of 10 newtons is applied to a stationary 2 kilogram block as shown in figure 528. The coefficient of static friction between the block and the floor is 0.75. The coefficient of kinetic friction is 0.45. Find the acceleration of the block. Well, we know we've got 10 newtons. The force is 10 newtons. The mass of the block is 2 kilograms. Mu s, static friction, is 0.75. And mu k, kinetic friction, is 0.45. The difference being the static friction, it's always harder to push that initial hump to get it over. And once it starts moving, it's easier. That's because the static friction is a higher value than kinetic friction. So first of all, we have to see if it's even going to move with a force of 10 newtons. So let's go ahead and do that. 2 kgs times 9.8 meters per second squared times 0.75 equals, let's see, 14.7 newtons. That force of 10 newtons will not overcome the force of static friction operating on the box, so it will not accelerate. Acceleration will be 0. We have no acceleration. 53. 53 says, a taut string connects a 5 kg crate to a 12 kg crate. The coefficient of static friction between the smaller crate and the floor is 0.573. The coefficient of static friction between the larger crate and the floor is 0.443. Find the minimum horizontal force required to start the crate. All right, so we're just going to add up all the frictions and then start the crate. We have 5 kgs here. And we have a 0.573. And we have 12 kgs here. And we have 0.443. And so we want to move it. We want to figure out what our force is going to have to be. So let's do 12 kgs times 9.8 meters per second squared times 0.443. That is for this crate, plus 5 kgs times 9.8 meters per second squared times 0.573. And that's for that crate. And add them all together, and we will get, let's see, 80.2 newtons. So anything less than that Just bump it up a slight bit over that and we're rolling. All righty. 57. 57. You have, okay, you've got a incline of 28 degrees. You've got this guy and this guy, and two blocks are connected over a massless frictionless pulley. The mass of block 2 is 8 kgs. This is 8 kgs. And the coefficient of kinetic friction between block 2 and the incline is 0.22. Block 2 slides down the incline at constant speed. What is the mass of block 1? All right, so we have the acceleration minus the force of friction, acceleration of 2 minus equals mg, m1g, right? This is accelerating down that way. The friction is stopping it, and that's going to equal this weight because they're in a static equilibrium scenario. All right, when you have a block on a ramp, the acceleration is always equal to g sine theta. I'm sorry, this is the force, okay? So yeah. And then we have the force of friction, and the normal force of a block on a ramp is going to always be equal to mg cos theta. All right. So we have 8 kilograms. This is times 9.8 meters per second squared times sine of 28. And that's providing the downward force minus the friction, because that's 8 kgs times 9.8 meters per second squared times cos 28 times 0.22. 0.22 equals m1g. So M1 is going to equal, if you do all the math here, well, we can always take all the g's out. So M1 will equal 2.2 kgs when you do the math, 2.2 kgs. So once again, you have the force pulling that block down. The force part, that part of gravity is g sine theta, always down a ramp. The normal force on an incline is always mg cos theta. And then we have a little friction. It's got a little friction, so we had to multiply that, this guy. And we are it's going at a constant velocity, so we have no, so everything's in equilibrium. So that's going to, the sum of the forces here, the sum of the forces there is going to equal the sum of the forces here. So practice this one. It's a good one. It's compelling. All right.